Imagine two perfectly healthy people waking up tomorrow with nothing to eat or drink. They are the same age, the same size, the same general health, and they are placed in exactly the same environment. There is only one difference. The first person has unlimited water, but absolutely no food. The second person has unlimited food, but not a single drop of water. No injuries, no diseases, no shelter problem, no extreme heat or freezing cold, just two human bodies, two missing necessities, and a clock that has started counting down. At first, the difference doesn't seem very dramatic. The person without food feels hungry. The person without water feels thirsty. Maybe both complain. Maybe both become uncomfortable. But they're still walking around, still thinking, still talking, still alive. And this is where the experiment becomes interesting, because your body does not treat food and water as equal problems. When food disappears, the body has a backup plan. It can change what it burns for energy. It can reach into its stored fuel. It can slow certain processes down. In other words, the body can look at an empty stomach and essentially say, "Fine, I'll use something else." But water is different. Your body doesn't have a giant hidden reservoir of water that it can slowly spend for weeks. Your blood needs it, your kidneys need it, your brain needs it. Every cell in your body depends on the right amount of water being in the right place. And when that balance begins to collapse, the problem isn't simply that you're thirsty. Your entire internal system starts having trouble maintaining itself. But here's the strange part. The person with no food might actually feel worse at first. Their stomach is screaming, their energy is dropping. Their body is demanding something that isn't coming. Meanwhile, the person with no water may still feel surprisingly normal for a while. They can still talk, they can still walk, they may even think they have plenty of time. And that creates the first trap. Feeling okay is not the same thing as being okay, because inside the two bodies, completely different survival strategies are already beginning. One body is preparing to change its fuel. The other is preparing to protect every drop it has left. And once those systems start failing, the difference between hunger and thirst becomes much more than an uncomfortable feeling. It becomes a race. A race between a body that can start consuming itself and a body that cannot afford to lose much more water. So before we ask how long either person can survive, we need to go back to the very beginning. What happens during the first few hours when the water simply stops coming? For the person without water, the first few hours are almost deceptive. Nothing dramatic happens immediately. The body doesn't suddenly shut down. There is no instant feeling of collapse. Instead, the body quietly starts protecting what it has. The first priority is simple. Don't waste water. Your kidneys begin reducing the amount of water leaving the body through urine. Your brain increases the signal for thirst, pushing you toward the one thing that can fix the problem: drink. But there is another system working in the background. A hormone called vasopressin tells the kidneys to hold on to more water. Urine becomes more concentrated, and the body starts treating every remaining drop as something worth saving. At the same time, you are still losing water. You lose it when you breathe. You lose it through your skin. You lose it through urine. And you may not even notice some of these losses happening. That's what makes dehydration so dangerous. You don't have to be sweating heavily for your water supply to shrink. Every breath carries moisture away from your body. Every trip to the bathroom costs you more. And your skin continues exchanging water with the environment. The person without food has a completely different problem. Their body still has fuel. There is glucose circulating in the blood, and there is stored glycogen in the liver and muscles. So during the first hours, the body doesn't panic. It simply starts using what is already available. The hungry person might feel hunger, irritability, or weakness, but internally, their body is already making a decision. Don't waste the reserves. The liver begins releasing stored glycogen to help keep blood glucose available, especially for tissues that depend heavily on it. It's like opening the first emergency fuel tank. And for a while, it works. But the person without water doesn't have an equivalent emergency tank. There is no secret compartment filled with enough water to keep the body running for weeks. Instead, the body has to constantly balance what little water remains against everything that is demanding it. And this creates a strange situation. The person with no food can still have energy reserves they haven't touched yet. The person with no water can have plenty of stored fat and muscle. And none of that solves the immediate problem, because fat can become fuel, muscle can become fuel. But neither can simply replace the water inside your bloodstream. As the hours pass, thirst becomes harder to ignore. The mouth becomes dry. The body starts conserving saliva. Urine becomes darker and less frequent. And the person begins to realize something important. This isn't ordinary thirst anymore. The body is beginning to defend its internal water balance. Meanwhile, the hungry person is still eating into the first layer of their reserves. And this is where the two survival strategies begin to separate. One body is changing its fuel source. The other is trying to reduce its losses. For the moment, both are still functioning. But neither body can maintain this balance forever, because eventually, the water-deprived person reaches a point where simply conserving water isn't enough. The body has to start choosing what gets protected and what gets sacrificed. And that's when thirst stops being a sensation and starts becoming a system-wide emergency. Now go back to the other person. He has water. He can drink whenever he wants. But there is nothing to eat. At first, this sounds like the easier situation. After all, he's not dehydrated. His blood volume is still being maintained. His kidneys are still getting water. His brain is still receiving what it needs to function. The problem is somewhere else: energy. The human body is constantly spending energy, even when you are doing absolutely nothing. Your heart is beating. Your lungs are working. Your brain is consuming fuel. Your cells are repairing themselves. Your body is maintaining its temperature. You are burning energy right now simply by being alive. And normally, food keeps replacing that energy. But our hungry person has just lost the supply line. For the first several hours, however, his body has an advantage. It has already prepared for this. The liver stores a form of readily available carbohydrate called glycogen. Think of it as a small emergency fuel tank. When food stops arriving, the body doesn't immediately start tearing apart muscle. It first uses what is easiest to access. Glycogen is broken down, and glucose is released to help keep blood sugar within a workable range. So the person may go through the first part of the day feeling hungry, distracted, maybe a little irritable, but still surprisingly functional. And this is important. Hunger does not mean the body is running out of energy. It means the body has stopped receiving new energy. Those are very different things, because this person has something the thirsty person doesn't have. Stored fuel. Inside his body is an energy reserve built over months or even years, fat, and fat is incredibly energy dense. That means the body has a way to continue operating even when food disappears. But there is a problem. Not every part of the body can simply switch to burning fat. Some tissues still need glucose. And the brain has traditionally relied heavily on glucose. So as the hours continue and glycogen stores become depleted, the body has to solve a much bigger problem. Where does the fuel come from now? This is when the body begins changing its strategy. The liver starts converting fatty acids into molecules called ketones. Ketones can provide an alternative fuel source for the brain. And that changes everything. Instead of constantly demanding fresh food, the body begins adapting to the absence of food. The hungry person is no longer simply waiting for his next meal. His metabolism is entering a different state. His body is effectively saying, if food isn't coming, we'll change the way we survive. And that is one of the strangest things about the human body. It was never designed around the assumption that food would arrive 3 times a day. For most of human history, there were no refrigerators, no supermarkets, no guaranteed breakfast waiting every morning. Food could disappear for hours, sometimes for days. So evolution gave the body a remarkable ability to switch between different sources of energy. But there is a limit. The body can burn fat. It can reduce energy expenditure. It can change hormone levels. It can even begin using protein when necessary. And that last part is where starvation becomes much darker. Because protein isn't just fuel. Protein is your body. Your muscles are made of it. Your organs depend on it. Your immune system depends on it. So when the body starts breaking down significant amounts of protein, it isn't simply burning an emergency fuel reserve anymore. It is beginning to dismantle itself. But the body doesn't want to do that. It tries to preserve muscle for as long as possible. It searches for another option first, and fat is that option. As long as enough stored fat remains, the body can obtain a huge amount of energy without immediately destroying large amounts of muscle. This means something that sounds almost impossible can happen. A person can go without food for a surprisingly long time, while still having enough energy reserves to keep the basic machinery of life operating. But remember the other person. He has unlimited food. He can eat as much as he wants. And yet, every hour, his body is becoming increasingly desperate for something that food cannot replace: water. That creates the central asymmetry of this entire experiment. The hungry person's body can reach backward into its own storage. The thirsty person's body can only conserve what it already has. And conservation has a limit. There is another difference too. The hungry person's body is adapting. The thirsty person's body is fighting to maintain a very narrow chemical balance. Blood needs the right concentration. Cells need the right amount of fluid. Electrolytes need to remain within a workable range. And the kidneys are constantly trying to keep the entire system stable. So while one person is changing fuel sources, the other is beginning to lose control of the environment inside his own body. For now, though, neither person is close to the end. The hungry person still has reserves. The thirsty person is still conserving water. Both can still walk. Both can still think. Both might even believe they have plenty of time. But that illusion won't last. Because once the body's first emergency strategies begin to run out, the two timelines start moving in very different directions. One begins burning what it has stored. The other begins losing the ability to control what it cannot replace. And the next stage reveals just how much the human body is willing to sacrifice before it finally admits that something essential is missing. By now, the two people are still alive, but their bodies are no longer operating normally. The person without food has entered a new metabolic state. The person without water is facing something more immediate. His body is trying to answer a brutally simple question. How do you keep a human being alive when the thing you are constantly losing cannot be replaced? The answer begins with conservation. The kidneys reduce water loss as much as they can. The brain keeps sending stronger thirst signals. Hormones push the body toward retaining fluid. The person may stop urinating as often. And when urine does appear, it becomes increasingly concentrated. It is the body's way of saying, nothing leaves unless absolutely necessary. But there is a problem with this strategy. The body is not a sealed container. Water is constantly being lost. Every breath carries water vapor out of the lungs. The skin loses water even when there is no visible sweat, and the kidneys cannot completely stop producing urine because the body still needs to remove waste products from the blood. So the body is fighting a battle it cannot permanently win. It can slow the leak, it cannot close it. And as the water level falls, something else begins to change. The blood becomes more concentrated. This matters because blood isn't just a delivery system. It carries oxygen, it carries nutrients, it carries hormones, it carries waste away from tissues, and it needs to circulate through an enormous network of blood vessels. When the body's water content drops significantly, maintaining that circulation becomes harder. The heart has to work against a system that is becoming increasingly difficult to keep properly filled. At first, the person may simply feel thirsty, then tired, then weak. A headache can appear. Standing up may make the person feel dizzy. And that dizziness is not just an unpleasant side effect. It is a warning that the body is struggling to maintain normal circulation. Meanwhile, the hungry person is having a completely different experience. He can drink, his blood volume is being maintained, his kidneys can continue functioning. But his metabolism is becoming increasingly dependent on stored energy. His body is now leaning harder on fat. And this creates an unusual advantage. Fat contains a tremendous amount of stored chemical energy, so the body can keep producing energy without receiving another meal. But energy isn't the only thing the body needs. This is where starvation becomes complicated. Food provides more than calories. It provides amino acids, electrolytes, vitamins, minerals, essential fatty acids. and other materials the body cannot simply manufacture from stored body fat. So even if the hungry person has plenty of energy stored inside him, that doesn't mean he has an unlimited supply of everything his cells require. The body can solve some problems by recycling its own tissues. But again, there is a limit, and the body knows this. It tries to preserve the most important structures for as long as possible. That means the metabolism doesn't simply burn everything equally. It becomes selective, it becomes economical. It becomes desperate in a very organized way. This is one of the most remarkable features of starvation. The body doesn't immediately panic, it negotiates, it cuts expenses, it changes fuel, it protects essential organs. It searches for every possible way to stretch the remaining resources. The person without water has much less flexibility. Water conservation is already near its physiological limit. And as dehydration becomes more severe, the consequences begin spreading beyond thirst. The mouth becomes extremely dry. Swallowing can become uncomfortable. The tongue feels dry. The skin loses some of its normal elasticity. Muscles may become weak, and the person begins moving differently, not because their muscles have suddenly disappeared, but because the entire system supplying those muscles is under increasing stress. Now imagine trying to survive while your body is becoming less capable of doing the things that could save you. You need to find water. But walking requires energy. You need to think clearly. But dehydration can affect concentration and cognition. You need to make decisions. But the physiological stress is already interfering with normal function. This creates a dangerous feedback loop. The worse the dehydration becomes, the harder it becomes to solve the problem causing the dehydration. And this is where the two experiments begin to separate dramatically. The hungry person can still drink water. He can sit down. He can rest. He can conserve energy. His body can continue switching between fuel sources. The thirsty person can do all of those things and still continue losing water. RET may slow some losses. It doesn't replace what is gone. There is another hidden problem. Temperature regulation. Your body normally maintains a remarkably stable internal temperature. When you become overheated, sweating helps remove heat. But sweating requires water. That means dehydration doesn't just make you thirsty. It gradually weakens one of your body's most important defenses against heat. The person without water therefore has a problem that can become much worse if the environment is warm. The hotter the environment becomes, the more water the body may need to lose in order to cool itself. But the more water it loses, the less capable it becomes of producing that cooling. It is another vicious circle. Heat demands water. Water loss reduces cooling. Reduced cooling increases heat stress. And increased heat stress increases the danger. The hungry person doesn't face this exact trap. His body is losing energy reserves. But energy can be stored in enormous quantities. A person carrying significant fat reserves is essentially carrying a large chemical battery. It isn't an infinite battery, but it is vastly larger than the body's readily available water reserve. This is why the timeline of hunger can be so different. The first day without food can be uncomfortable, the next stage can be exhausting. But the body has an entire survival strategy built around the possibility that food may not arrive. And that strategy is already running. The person without water has no comparable long-term backup. His body can conserve, it can redistribute, it can slow losses. But eventually, the chemistry of the blood begins to move outside the range that cells can tolerate. And this is where the story becomes much more serious, because cells are not simply little bags of water. They operate through carefully controlled concentrations of salts, ions, proteins, and other molecules. Too much water can be dangerous. Too little water can also be dangerous. The body therefore spends enormous effort keeping these concentrations within narrow limits. Dehydration pushes that balance in the wrong direction. And the brain is particularly sensitive to changes in the body's internal environment. That means one of the first places where the consequences may become obvious is not the stomach, not the muscles, but the mind. The person may become unusually irritable. Their concentration may worsen. They may struggle to think as clearly as they normally would. And eventually, severe dehydration can produce confusion. That detail changes the entire survival experiment. Because imagine knowing that you are thirsty, but gradually losing the ability to accurately understand how dangerous your situation has become. The body isn't just losing water. It may be losing the ability to respond intelligently to that loss. Meanwhile, the hungry person is becoming weaker too, but his body is still adapting. His metabolism is still using stored fuel. His brain is still receiving energy. His body is still conserving resources. The difference is becoming clearer. Hunger forces the body to change its strategy. Dehydration forces the body to defend a system that has very little room for error. And yet, there is something the hungry person has not escaped. His body may be brilliantly adapting to the absence of food, but every adaptation has a price, because once the easiest fuel reserves begin changing, the body has to decide what it is willing to sacrifice next. And that decision eventually leads to one of the most unsettling questions in the entire experiment. How much of your own body can you lose before your body can no longer keep you alive? That is where prolonged hunger stops being a story about an empty stomach and becomes a story about the body slowly deciding what parts of itself it can afford to keep. The hungry person has now reached a point where his body can no longer pretend that this is just a missed meal. Food still hasn't arrived. But something remarkable is happening. His body is getting better at surviving without it. Most of the easy fuel is gone, so the metabolism leans harder on stored fat. The body lowers its energy demands and becomes more economical. But there is a limit to how much fat can solve, because eventually, the body needs materials that fat cannot provide. And that creates a terrible choice. What do you burn when the fuel tank is getting low, but the machine still needs parts? The answer is protein, and protein means tissue, muscle. The body begins taking apart some of its own structure to keep essential functions running. But even here, it doesn't simply destroy everything randomly. It tries to be selective. It wants the heart to keep beating. It wants the brain to keep functioning. It wants the most essential organs protected for as long as possible. So the body cuts back wherever it can. Movement becomes harder. Strength falls. The immune system becomes weaker. The person becomes increasingly vulnerable to illness. The strange thing is that this process can continue for a surprisingly long time. Compared with what most people imagine, the body is essentially stretching every remaining resource. And that is the hidden advantage of hunger. It gives the body time. Now look at the person without water. His body has no equivalent strategy. It cannot decide to burn fat instead. It cannot convert muscle into water in any useful way. It can only conserve what remains. And conservation has a ceiling. Once enough water has been lost, the problem spreads. The circulation becomes harder to maintain. The kidneys struggle. The brain begins to suffer. The person becomes weaker and less coordinated. And eventually, the body starts losing its ability to keep its internal chemistry stable. This is where the difference becomes brutal. The hungry person's body is sacrificing resources to preserve the system. The dehydrated person's body is losing the resources required to keep the system running at all. And there is another reason thirst can become so dangerous. The brain itself is part of the survival problem. As dehydration becomes severe, confusion can appear. The person may no longer think clearly enough to understand how close they are to collapse. Imagine being trapped in a survival situation where the most important thing you need is water, while your ability to make good decisions is gradually disappearing. That is a very different kind of countdown. Hunger can make you weak. Thirst can make you lose the ability to respond. And now the two timelines are beginning to converge. The person with food but no water has been losing something his body cannot manufacture in sufficient quantities. The person with water but no food has been spending something his body can store in enormous quantities. One body is running out of a resource, the other is learning to live on its reserves. But there is still one final question. How far can that adaptation really go? Because eventually, even the person with unlimited water reaches the point where fat reserves are no longer enough, muscle loss becomes dangerous, and the body can no longer maintain itself. The hungry person has a slower countdown, the thirsty person has a faster one. And once the final stages begin, the difference is no longer measured by how uncomfortable they feel. It is measured by which body's essential systems fail first. So now we can finally put the two timelines next to each other. No more assumptions. No more guessing. Just the final race between a body running out of water and a body slowly consuming itself to stay alive. Now put the two people side by side. One has no food. The other has no water. Both are getting weaker, but they are not running out of the same thing. The person without food still has stored energy. His body can burn fat, reduce its energy demands, and sacrifice some tissue to keep the most important organs functioning. It is a terrible process, but it is a process that can buy time. The person without water has far less room to negotiate. His body can conserve water, it can concentrate urine, it can increase thirst, it can slow losses, but it cannot create a replacement supply. And eventually, the systems that depend on that water begin to fail. The heart struggles to maintain circulation. The kidneys can no longer keep up. The brain becomes increasingly impaired. The body's internal chemistry moves further away from the narrow balance required for life. And this brings us to the answer. Thirst wins. A human will generally die from a complete lack of water much sooner than from a complete lack of food. But the interesting part isn't simply that water is more important. It's why. Your body has evolved a remarkable emergency system for hunger. It can switch fuels, it can burn fat, it can reduce its energy consumption. It can even break down its own tissues when necessary. But when water disappears, there is no comparable backup reservoir. You cannot simply switch to another form of water. You cannot burn fat and replace the fluid circulating through your blood. You can only slow the loss. And once that reserve falls far enough, the entire system begins to unravel. So the two people from our experiment face completely different clocks. The hungry person is slowly spending what the body has stored. The thirsty person is losing something the body cannot afford to lose. One body can adapt, the other can only delay. And that may be the strangest lesson of all. Your body can survive without its next meal. It can survive by changing its fuel, consuming its reserves, and sacrificing pieces of itself. But without water, there is eventually nothing left to negotiate with. The clock simply keeps moving, and the thing that finally kills you isn't the feeling of thirst. It's the moment your body can no longer keep the chemistry of life in balance. And if you enjoyed discovering what really happens inside the human body in extreme survival situations, subscribe to the channel, because there are a lot more questions about the human body that sound simple until you look at what is actually happening underneath. And trust me, some of the answers are stranger than you expect.